right, so today we're going to identify the effects on graphs. Now again, I think we've already done all of this stuff when we've graphed these functions, but today we're just going to talk about it in words, what's really happening. So if you look at these four equations right up here in this first table, what kind of graphs are all of these graphs? They're parabolas, good. We can tell that because of the 1x squared term, okay? So my question is on my table right here. It says, for each of these parabolas, tell me whether it opens up or down. Does anybody remember how to tell if it opens up or down? The negative. The negative where? In the front. So this one has a negative in front. So does it open up or down? Down, you're right. What about this next one? Down again because of the negative out in front. Next one? Down because of the negative in front. And the last one? Up because it's positive out front. Now we already knew that information, right? When we graphed them, we decided if they were smiley face or frowny faces according to the sign out front. Now the next two questions say, choose the parabola with the narrowest graph and choose the parabola with the widest graph. So I want to flip my paper over for just a minute and just show you what narrow and wide means. Do you guys agree that this would be a narrow graph and this would be a wide graph? Yes? Okay. How do I get my graph to be narrow like this, and how do I get my graph to be wide like that? Do you remember what we did on our patterns? We changed it. We multiplied our pattern by something, right? How did we get it to go skinny like this? Does anybody remember what we multiplied by? What? No? I thought you might have said something. Negative. Nope, negative flips it upside down. Positive. Okay? So think about this for just a minute. Say I'm going to multiply by 2, or say I'm going to multiply by 1/2. One of these makes it narrower, one of them makes it wider.
2 makes it wider and the 1/2 makes it narrower.
Okay, so think about my patterns. My pattern is 1, 3, 5 on my graph. You guys agree with me that? 1, 3, 5, 7, 9. This pattern is going to change to be 2, 6, 10. So I would go over 1, up 2, over 1, up 6, over 1, up 10. This one's going to be over 1, up 1/2, over 1, up 3/2, which is 1.5, and over 1, up 5/2, which is 2.5. Which one's going to get me fat and which one's going to get me... Okay, this one's for sure skinny, right? Because over 1, up 3, over 1, up 6. Do you see how fast it's growing vertically? Where this one's barely growing vertically, right? So a whole number out in front is going to give me a narrower graph. And a fraction that's less than 0. And I added that part in there to remind yourself that like 3/2 is bigger than 1. It's going to grow bigger than the original graph, right? But if you have a fraction that's less than 0, it's going to go wider. Okay? So, knowing that now, which parabola is going to be the narrowest, the skinniest parabola? Now we know a whole number out in front makes us narrow, right? So which one of these, the 4 or the 2, is going to change my pattern so it just jumps like crazy on the y's? The -4. So this one right here is my narrowest graph. You following me on that? So really what we did was we found the biggest number. The biggest number is going to make my change on my pattern happen the fastest. So with that same thought, how do I make it wider? I look for the smallest number in front. So which one is the smallest number? The 1/3. So this would be the graph that is the widest. Does that make sense to everybody? Now again, haven't we already done that? We've figured out already how to graph them to make them skinnier and fatter, right? But today we're just talking about how it happens. All right. This next table right here gives me this original graph right here. My original graph is the absolute value of x. Then I'm just changing the function of my graph here, and I'm moving it left or right or up or down, or I'm flipping it upside down. I'm changing the pattern. I want you to tell me what we're doing. We're not going to actually do it this time. We're just going to say what we're doing. Does anybody remember what the +2 inside the parentheses on the X is going to do?
Can I move it to, no.
It is to the left. So this is to the left 2 units. Okay? I'm moving left 2 units because the plus on the X means left. Anybody remember what -4 is asking me to do? It says take this entire graph and move it where?
Down.
Yes. This one's going down 4 units. What's the +3 doing right here?
To the left.
Yeah, it's left. The -1,
Is down one.
it's down 1. The negative out in front. What's the negative going to do to your graph? Instead of looking like this, what's it going to look like?
Upside down.
Upside down. So before we would call that upside down, or we would say that flips over. Now we're going to call that it reflects. Okay? It flips itself upside down. You can call it reflection. I'm really not going to mark you wrong if you put upside down, but it's really a reflection. Okay? And then what's this 2 out front going to do? It changes the pattern, which is what we said before. But does it make it wider or narrower? Narrower. Okay, nice job. And it makes this narrower, the amount of our pattern being times by 2, right? So you guys remember that from when we did that. All right. Same kinds of question as the bell work today. It says compare the graphs of y equals x with the graph of y equals 3/4 x. Now, do you remember I said be careful with those fractions, right? So think about it for a minute. It says which graph is steeper? Steeper is the bigger slope. The slope here is 1. The slope here is 3/4. Which number is bigger? 1. So it would make sense that the steeper graph would be y equals x. Now, someone said to me earlier, they're like, Mrs. Clark, that doesn't make sense at all. Here you go up 1 and over 1, but here you go up 3. So how does that work? And I said, well, let's graph it and figure it out. So I just want to graph it so you believe me, okay? And my graph is kind of crooked, but if I'm graphing y equals x, I would start at 0 and I go up 1 over 1, up 1 over 1, and my graph would go through those ordered pairs. So that's my y equals x graph, okay? If I'm graphing this one, I'm starting at 0, 0, but I'm going up 3 and over 4, which is clear over here, like that. Which graph was the steepest? The y equals x, right? Because 1 really is bigger than 3/4. Even if you count it as up 1 over 1 or up 3 over 4, it's still smaller as far as slope goes. Okay? The other question says which graph has the greater y-intercept? Well, these both started at 0, so they really don't have one that's greater. They're actually the same. But let's take a look at a couple of equations and say, let's say I have y equals x plus 3 and I have y equals x minus 3. So these both being my y-intercept, which one is greater? The positive 3, right? This one has the greater y-intercept because it's the biggest number or the highest number on the y-axis. Okay? So again, we've talked about all of this stuff before, right? It's just being asked to you in a different way. All right, this next one says write an equation for the function after its vertical translation. So vertical means up and down, right? So we're moving this sucker up and down. What would it say if we were moving left or right? Do you know? What goes left and right? Horizontal, you're right, okay? So it says, here's my original graph. H of x equals 2x squared plus 1. And I want to move this up 7 units. So I need to take this equation and I need to make it show that I'm moving up 7 units from here. So tell me what this plus 1 tells me that I've done. It says I've already moved up 1 unit, right? If I need to move it up 7 more units, what's this number going to be? Say it louder. It's going to be 8. So to take this graph and move it up 7 more units, I would now be up at 8. Okay? Now tell me this. Say I asked you to take this graph and move it 2 to the left. Could you take this graph and rewrite it so it was 2 to the left? Wouldn't that just be 2 times x plus 2? Because that would be 2 to the left, right? Plus 8. So we can take any graph that we want and just keep moving it left or right or left or up or down or whatever, depending on what we do to the new equation. Okay? All right, last example here. It says below is the graph of x squared, which is my graph right here. It says make it be this graph, y equals x minus 3 squared. What does the minus 3 say we did to this original graph? We moved it to the right 3. So all I have to do is rewrite this. So I've moved it to the right 3. So this ordered pair moves right 3. This ordered pair moves right 3. That ordered pair moves right 3. Really, we just picked up the whole graph and moved it to the right 3. And we regraph it. Okay? That's called a translation. When we translate, we move left or right or up or down. Okay?